All right, Module 4, enumeration. In this module, we've already done some enumeration. We've been enumerating ports, enumerating hosts, we've been enumerating services, and so forth. In this module, we're going to focus in on a couple specific types of machine-based enumeration, which a lot of it goes around enumerating user accounts and verifying user accounts in the system. So this is one of our shorter modules in the course. We're going to be doing the same sorts of techniques that we've been looking at, just different tools for scanning like a range of systems, identifying listing services and so forth, and then also doing like SNMP probes, scanning for users on the machine. So we're going to be using tools to perform enumeration. We also have some command line functionalities as well. And we're going to be looking at what is enumeration, techniques for enumeration, services and ports to enumerate, NetBIOS enumeration, enumerating system using default passwords, SNMP enumeration, Unix and Linux enumeration, or enumerating from Unix and Linux, LDAP, NTP, SMTP, and DNS enumeration, enumeration countermeasures, and then enumeration pen testing. So, defined, what is enumeration? We've already defined what enumeration is. It's sort of listing the details out of a specified search context, wherever that search context may be. But in this case, we're noting network resources and shares, users and groups, routing tables, audit and service settings, machine names, applications and banners, SNMP and DNS details. So we use this information, like anything else we've gathered to this point, to identify potential attack points. So user enumeration, identifying user accounts to authenticate as, break passwords, and so forth. Enumerating resources and shares for gaining access to different data sets, etc. And again, we've got a few different flavors of enumeration we'll be looking at in this module. So attackers use the extracted information to identify system attack points and perform password attacks to gain unauthorized access to information system resources. Enumeration techniques in this discussion are conducted inside of the intranet. Now, with that being said, we actually have a couple things that can be conducted to the DMZ and so forth. So not totally true, but for the most part, this is all stuff that's inside the network, inside the perimeter. So techniques for enumeration. Extracting usernames using email IDs. Huh? Well, what happens if the username is exactly the same as the email address? Now, sometimes to avoid confusion, the user's login, their UPN, user principal name, matches the email address that they use for corporate email. So the idea is if we have an email from this person and they are one and the same as their username, now we've got their usernames. So that could allow sort of brute force attacks and so forth. We can also deduce their actual names, the employee names from the email ID, which oftentimes that's pretty easy to put together. First name dot last name especially, there you go, there's the first and the last name right there. First initial dot last name and so forth, and some different possibilities around that. Extracting information using default passwords. We have default passwords configured for default configurations. A lot of times we see this on like appliance devices, like router switches, access points, and so forth. If that information hasn't been changed, we can look that stuff up on the internet. We actually have websites dedicated to default passwords. And that'll actually come back up in a couple different modules, come up as a point of discussion. Brute forcing Active Directory. Sounds great, but brute forcing Active Directory is generally going to get you locked out. So we'll talk a little bit more about that. Extracting information using DNS zone transfer. We've already looked at the DNS zone transfer as a possibility under like NSLOOKUP. You can also do zone transfers, with different utilities as well, but quite often, more often than not, that's going to be blocked. Extracting user groups from Windows. Extracting user accounts from Windows, the groups they belong to can indicate different levels of access. Extracting usernames using SNMP. So we'll use Simple Network Management Protocol to do some enumeration as well. And that's actually going to grab some of the information we've already seen with other utilities like listening ports and so forth. All right, services and ports to enumerate. TCP UDP 53 deals with DNS, zone transfers and queries. Our 135, 137, 138, and 139 are all NetBIOS ports. So you've got the endpoint mapper for remote procedure calls. You've got the name service for 137. 138 is the datagram service, which we're not listing on the slide here, but hey, while we're talking NetBIOS, let's throw that in there as well. And then 139 for the actual session service. 445 is for server message block protocol over straight IP. So NetBIOS is a Microsoft proprietary protocol that is still configured and still in use even on newer machines, even though we haven't had to use that since 2000 came out back in the year 2000. So server message block over direct IP doesn't require NetBIOS. You have a different communications point for the server message block protocol. and that was for sending and sharing files, sending print jobs, establishing a connection with the inter-process communication share, extracting information about the machine. UDP 161 is for SNMP. SNMP is generally weakly configured, and if you find an SNMP listener, there's a good chance you're going to be able to extract some useful data from that. UDP port 389 indicates a LDAP server. In a nutshell, you see a 389 listener, we're probably looking at Active Directory Domain Controller. Port 88 should be thrown in there as well. While we're talking about recognizing Microsoft domain controllers, that's for your Kerberos protocol. 3368 also identifies a subset of domain controllers in a Microsoft environment, the Global Catalog Server. Global Catalog Server will maintain an entire domain partition for the domain it belongs to, and then a subset of attributes for all other objects in other domains within the given forest. So it's used for searching for objects across multiple domains. Also identifying a domain controller. 25 identifies a mail server, simple mail transfer protocol, and port 162 is SNMP trap. So NetBIOS enumeration. All right, NetBIOS enumeration, we have the NetBIOS protocol that can be used to request information from a machine, and we can look for things like its NetBIOS name. We could also grab, using like netuse commands and so forth, grab information about the machine, establish a null session, which we'll talk a little bit about that. We've got a data vulnerability, but also a possibility of being resurrected with a registry key flip. So I'm actually going to do some null session discussion as well. Hang on to that thought, we'll get right to it. But using NetBIOS, which we've already seen this name table enumeration, we saw that in our Nmap scanning tool. So grab the NetBIOS name table, we did that within Nmap. But I can use NBTSTAT to actually retrieve that directly. So NBTSTAT can be used to examine the local name cache and also identify the remote table, its NetBIOS over TCP/IP statistics. I can also use that to deduce the name of the remote server based on its IP address. So if I go into my 2012 box, for example, and I do an NBTSTAT-C, oops, did an AC there, that's not going to work, -C, it shows me my local NetBIOS name table. We have no names in the cache. So this can show me if I'm on the box and I'm trying to identify other machine names on the network, this name cache will show anything that's been resolved via NetBIOS in the last 15 minutes. So we actually have 3 caches we're going to be talking about over the course of the course. Let's go ahead and list them out now, and we'll come back and take a look at them. You have the NetBIOS resolver cache and the WINS cache, interoperable. You also have the DNS resolver cache, and you also have the ARP cache. So your timeouts for these guys, they're going to cache information for later reuse for, like, okay, under NetBIOS name cache, systems I've resolved using NetBIOS name resolution for over the last 15 minutes. DNS resolver cache will be any DNS records or host names that we've resolved to their IP address based on the TTL value of the record itself. So generally that's 60 minutes. That's one of the sort of the defaults. You also have the ARP cache, which in Microsoft systems is 2 minutes, Linux systems 5 minutes, where you look at anything that's been resolved from an IP address to a MAC address recently for the purpose of addressing your packets. All right, so enough said on that. We'll come back to that. I can also do an NBTSTAT-A IP address 192.168.7.200, for example, and that comes back with the NetBIOS name table for the remote system. So we see that it's a victim system, it belongs to a work group, and a couple different iterations of that. Okay, this hex appearing here identifies like the messenger service, the server service, the workstation service, and so forth that the system is running on. You also get the remote MAC address. All right, so NBTSTAT can be used to identify machine names based on IP address, retrieve the name table, also look for the different services running on that box. All right, so NBTSTAT-C we looked at, that resolves the name cache itself. And then we also have a utility like SuperScan. Before we go to SuperScan, I want to show you the manual establishment of a null session and the difference between a null session. This is actually against our 2000 box. And I'm going to talk about the differences between the null session restrict anonymous settings in later versions of the operating system.